Good morning. Today we're going to have a look at angles of elevation and depression. Now the angle of elevation is the angle measured upwards from the horizontal. So this is our angle of elevation here. It represents if we were on the ground and we were looking up, for instance, at the top of a cliff. Now the angle of depression is the angle measured downwards from the horizontal. So if we're standing here and we're looking at something down, it is the angle between the horizontal and where we're looking down. So what that means is that, what we can see here is that they're both the angle between the angle we're looking at and a horizontal line. So those two horizontal lines are parallel. And so if we have two lines that are parallel, what we have learnt is that if we have a transversal cross those, then they form alternate angles. So that theta, both those angles are the same. So what that means is that if we're doing an angle of depression question and we set up our diagram and we find that when we do our lovely triangle that we don't have theta inside that, what we can do is we can transfer theta down into it by moving it to the angle of elevation. So we'll probably see an example of that, but what it says here, it says this information is useful to solve some problems. That's what it's talking about, that sometimes perhaps the fact that the angle of elevation, the angle of depression, we can transfer them across and they can help us solve. Okay, let's have a look at the questions we've got. So the first one is looking at this, asking us to sketch an angle of elevation. So the angle of elevation to the top of a building to a point 50 meters from its base is 48 degrees. Draw a diagram to illustrate this information. So the first thing I'm going to do is just do a building. Then what I'm going to do is I'm going to do the ground, which I know that I'm doing it. You hopefully are using a ruler, and I hopefully am going to get this pen to work. It's very frustrating. I had a pen that always worked, and I managed to break it, and now I've got a new one that doesn't work very well at all. Okay, so from the top of the building from point 50 meters from its base. So here we go, that's where I'm going to be. So that's going to be 50 meters. Now it's an angle of elevation to the top. So I'm drawing a line and it tells me that it is 48 degrees. So there we go, 48 degrees in there, hopefully. 40, no. Not sure why. Sorry, I'm persevering. I'm not sure why we are not having such difficulty with this pen. Okay, I managed to scribble 48 degrees in there. So that's what my diagram could look like for that one. Having a look at my next one, sketching an angle of depression. The angle of depression from the top of a vertical cliff 56 meters high to a ship at sea is 27 degrees. Draw a diagram to illustrate this. Okay, so my cliff perhaps is going to look like this, hopefully. There's my cliff, and now what I'm going to have is I'm going to have a sea. Here's my sea. And a ship at sea is out here somewhere. Let's do our ship. Alright, so out here we're just going to have a ship. Now what I'm going to do is, I could draw a ship, I guess. There we are, there's my ship. So what I need is, I need something, a line of sight which comes down to that. And what it tells me is that the angle of depression, so our angle of depression is the angle between the horizontal and our line of sight. So it sits up there, it's 27 degrees. The cliff is 56 meters high, so we need to put that in. And that is a diagram which will demonstrate that information. Now what I was talking about before is that we can see, if for instance it asks me how far away it is from shore, this 27 degrees I put in there is not actually in that triangle. So what I can do though is I know that my angle of elevation is also the same. They're alternate angles, so I can transfer that down to there. All of a sudden now, if I'm trying to find that distance, X meters, I have the ability to be able to then use SOHCAHTOA because it's all in the same triangle. So let's have a look at an example. A park ranger measured the top of a plume of volcanic ash to be at an elevation of 41 degrees. From a map, she noted that the volcano was 7 kilometres away. So here's our information here. Calculate the height of the plume. So there's our 7 kilometres away. There's our 41 degrees. Now, one of the things which hopefully you'll soon come to realise is that for our angle of elevation and angle of depression problems, they're pretty much every single one is a TOA. We're pretty much always dealing with, that didn't work very well, I was after that one. We're pretty much always dealing with, never with H, we're pretty much always dealing with O and A. So our 41 degrees, O, and our 7Ks is our A. So we're pretty much always going to be TOA in every problem that we look at. Okay, so let's set that up. Now we've got 10, 41 degrees is equal to O on H. So I missed that. Tan theta equals O on H. Tan 41 is O on 7, or X on 7 if we want that. We're looking for one on top. So what we're going to do is we are multiplying together. O equals 7, 10, 41 degrees. If I put that into my calculator over here, I have 7 times 10, 41 equals 6.08. I'm pretty sure that was 5. I need to bring the calculator back up. 6.085. So the 2 decimal places, that's going to be 6.09 kilometres. So it is 6.09 kilometres high. Now if I just wanted to do a reality check on that to see whether I thought I got it right, remember that 45 degrees is our 1-to-1 ratio. So under that scenario, O and A would be equal. Now 41 degrees means that it's not going to be quite as high. O is going to be less than A. And we have a look at that, it's 6.09 in comparison to 7, so it seems reasonable. My answer seems reasonable, so it's not a bad idea to have a look at your angle, have a look at your answers, and then go, is it in the right proportion to the angle, or sorry, to the side which has been given us. Alright, so let's have a look. Finding a distance using an angle of depression. The top of a cliff is 85 metres above sea level. Let's do my cliff, 85 metres. Min saw a tall ship. He estimated the angle of depression to be 17 degrees. So let's get him with his ship all the way out here. Let's get our angle of depression at 17 in there. And let's also put our 17 degrees down the bottom there. How far was the ship from the base of the cliff? So to make that X meters, answer to the nearest, sorry, how far was the ship from the base of the cliff? Answer to the nearest meter. All right. So, I'm sorry, I've used up all the space with my very big diagram in the notes themselves, so I haven't done that. What I'm going to do here is I've got TOA. If I have a look at what I've got, actually I should mark it, I should still be labelling them. I've got H here, there's my angle, I've got O here, A here. So I'm looking for X is A, so TOA, 10 theta equals O on A. If I transfer the numbers in, 10, 17 equals 85 on X. Now X is on the bottom. If you can recall when we did this, I said what we want to do is we want to learn to swap. X is on the bottom, swap. X equals 85 on 10, 17 degrees. And that is going to be equal to, apologise for the awful, sorry I won't use that calculator, let's go for this one. We've got 85 divided by 10, 17 degrees. equals 278. So it is 278. We have to do it to the nearest meter, 278.0, 278 meters, 278 meters. Now, second one, part B, is asking us how far is the ship in a straight line from the top of the cliff. Answer to the nearest meter. Now, what we should do, because that 278 is not exact, and we want to get our answer, we want to use the most exact stuff that we can. What we're going to do is we're going to use the information that's been given to us. Now we're looking for the straight line distance, so that is h. We've been given O, so let's use sine. Let's use SO to do this problem. We've got all three sides now, so we could use any, but SO, because we know it's 85 meters exact, and the other one, even though we rounded it to 278, let's use SO. So we've got sine theta equals O on H. So sine 17 degrees is equal to 85 on H. So H is on the bottom. If we've got on the bottom, then we swap them. H equals 85 divided by sine 17 degrees. My answer is, H being the hypotenuse, the distance in straight line. That is, back to the other calculator, 85 divided by sine 17 equals 290.7. So 290.7, I'm going to round that up to 291, equals 291 meters away in direct sight, as in a direct straight line from the top of the cliff. Okay, let's have a look at our last one. This first example came from Cambridge, another one here coming from Oxford. This one's got a diagram for me. Using trigonometry to calculate the angle of elevation or depression. So this is different. The first one we were finding a side, now we're going to actually find the angle. A building is 40 meters high. Calculate the angle of elevation to the top of the building from a point that is 36 meters from its base, correct to the nearest minute. So we're after this angle here, theta. So if we label them, we'll see, as predicted, that our problem is going to be a TOA. So we're going to use TOA to find that angle. So we're simply going to have tan theta equals O on A. So tan theta, we substitute in those values, 40 on 36. Theta equals tan minus 1, 40 on 36. If I come across here, put that in my calculator. What do we got? So we'll cancel all that stuff if I can find the right button. And let's just go with second function, tan 40 on 36. So I'm going to use my brackets, 40, and I'll use my fractions on 36. I'm going to close my bracket so I know that's right. I'm looking at that calculator, I know my calculator is not going to do anything silly to me. And my angle is 48 degrees. So what does it say? It's the nearest minute. So if I write that down in the first place, 48.01 I think it was. But we're going to come back here. What I'm going to do is, I need to get it degrees, minutes, seconds. This calculator, remember it's the orange one up there, 2 degrees, minutes and seconds. Second function, degrees, minutes, seconds. It's given to me 48 degrees, 0 minutes, 46 seconds. So I've got equals 48, 0, 46. So this, you might say, was a bit of a trick, because if I looked at the 0, it's to the nearest minute. And so what 46 seconds is actually going to be rounded up to 1 minute. So my answer is going to be 48 degrees and 1 minute. Okay, so you've got quite a few problems in here to do. Cambridge is some there, Oxford is some there. I'll go through and put some colours on some of those, and I might also just look up some smarter maths ones, see if I can find some HSC type questions with elevation and depression as well. If you've got any questions, please send me an email.